उनका सिस्टम। ये देखिए जो 4 पार्ट सर ने बताए थे ना आप लोगों को 1 2 3 4 करके। 1 इज द कैंटिलीवर। सो कैंटिलीवर बिलोंग्स हियर डाउन साइड। ओके, ये है हेड। दिस इज द हेड, मोस्ट सोफिस्टिकेटेड थिंग ऑफ AFM. Okay, we have to put it on its holder. Okay, so this is the head and this is the cantilever. That is see, you can see a line, sharp line. Okay, yes, you all can see this is a sharp line in the mid of this. Actually that is the cantilever. Okay, it is not tip, it is cantilever, and tip is at the end upside. Okay, pointing upside, you cannot see. Okay, so this is the cantilever hand overall. Coating is on this side, on cantilever. You cannot see. That is quite small. But so this is what we call it tip overall. But that tip is way more smaller, and we can hold it up. So that is the head, and we are mounting tip on its head. Okay. So it is a kind of magnetic. So we have to. Yes. So we have to carefully put it, and we do not apply force on this head. Okay, because it is also made of some piezo. Okay. So the next, that is the first component, the cantilever. Okay. Then it comes here the stage, which is also piezo. Okay. So this portion, this white portion, is of piezo material. Okay. So inside there is the piezo, which goes left, right, top, bottom. Okay. So kind of X, Y, Z movement in this also. And here is the sample. It is also magnetic stage. So you can see the sample. You all can see. It is provided by the company and it's standard sample. So I will show how it looks like. So this is the sample. Okay.
ये sample क्या है?
I'll show.
नाम क्या sample?
It is nothing but gold. It has gold patterns. Okay.
मतलब हम जब sample लेंगे जो ceramic sample उसको कैसे लेंगे?
No issues, sir.
No.
Let me tell you. Let me tell you one by one. Sample preparation part I will tell you. Okay. So see, you can only see the sample. Okay.
Okay.
But you cannot find the height of the sample. It is like nothing. Nothing. Okay. So you have got the idea now, like how to prepare sample. Okay. That is the precision. You have to prepare samples like
Ultra thin.
okay, ultra thin. That should be ultra thin. That's how it should be dispersed. That's why we do. Okay. We have magnetic. Now, so that is one. This is two, and the third part comes in this C, in this head. There is prism. Okay. So there laser light comes, and then revert. This is the prism. Okay. So laser light comes and falls on the tip. Okay, cantilever. So and reflected back to the PSPD. PSPD is this position sensitive photodiode. Okay. So here is the PSPD, okay, position sensitive photodiode, and these two knobs are for aligning laser, okay, that is falling onto the cantilever, top of the cantilever, okay, and whose reflection is being shown here, okay, it is the reflection of the laser over PSPD, position sensitive, that is what it is working on that principle, position sensitive photodiode. So the reflection is guiding the topography. So we have to, these are the photoreceptor knobs. We have to align this green dot in the center. Okay.
सब बैक करिए उधर देखिए.
Okay. Yes.
So we have to maintain it to 0.0. Okay, 0.0. Okay. As we will approach, it will deflect again. Okay, so we have to maintain it for even when we are approaching to that. Okay. So now let's go down first. I am moving the head through a motorized motor. Okay, the head will go down now. It is just we have to be very careful that it should not hit the center. Okay.
ये देखना है कि ज्यादा नहीं नीचे जाना, ज्यादा नहीं ऊपर जाना.
ज़्यादा ऊपर नीचे की बात नहीं है. We have to just focus the sample first.
Okay.
So we are now approaching to the sample and focusing the sample actually. So this is again the tip, cantilever, and now we have to manage this vertical and lateral potentials. The vertical potential is like, we should not ignore the vertical potential because the vertical potential is defining the z-axis of our sample. So at any cost, vertical should be optimum 0.0 case. Okay. So
अभी तक तो नहीं हुआ. 0.0 ही.
it is 0.0. It should be 0.0. Okay. And what about the sample? Where are we? Let's see first. We are at the edge. Okay. Now going to the sample. See. First, let us go here.
ये जो स्लाइड ली तो उस वाला स्लाइड.
Sorry?
ये जो स्लाइड ली तो वो वाला स्लाइड छोटा सा.
हाँ भैया, ये वो है, उसके सेंटर में भी ये है, ये जो
सेंटर में जो ब्लैक वाला हुआ था.
नहीं है, वो आपको अभी दिखा देंगे फिर से आपको. ठीक है. So that is it. And now again we have to set the vertical.
This is vertical. Horizontal 2. Vertical is 1.
Vertical is A minus B. A is upper, B is overall down.
The C minus D. अभी जो कर रहे हैं आप.
Yes.
ऊपर A minus B. लास्ट वाला जो कर रहे थे वो A plus B. टोटल सब का.
Yes, yes.
Okay.
Okay. So now I am focusing the sample. Again.
वर्टिकल में फोकस करना है.
ना वर्टिकल में नहीं फोकस कर रहे.
अभी तो
मैंने उसको सेट कर दिया है. Okay. This is now being closed. So see, we have variety of modes. Here in the setup, we have to choose the cantilever. Like which cantilever we are using. It is mentioned over here NCHR. Okay. So this is non-contact cantilever. It is NCHR. So we have selected NCHR. Okay. Otherwise there are many. See these many types of cantilevers we have. Okay. For
आपके पास only non-contact cantilever.
no, we have all non-contact, contact, MFM, EFM for every we have.
तो मोस्ट प्रोबेबली
Different
इसको यूज कर सकते हैं.
We use non-contact mode for topography. Okay. Like simple topography.
दूसरे का यूज करेंगे तो
So you can use for other purposes. Okay, so we have selected NCHR. and then this NCM, non-contact mode. Okay, there are these modes are available with this system.
Contact
CPFM, FMM, MFM, EFM, external DC, or CP. This is EFM external DC. This is EFM, simple EFM. Tapping, non-contact. So there are all contact, non-contact. So now what we have to do is, it is test. Okay, we have to select the folder first where we want to save it. Okay, so it is data and save.
Karyashala.
So we have selected this folder and now it is test. We are going to start the line scan. Okay. So now we have started the line scan. Now what is going on there? 2.5. Let me do this rate so that you can see the animated version here.
0.5 scan rate.
Yes. Otherwise, if I go to a higher scan rate, it will not show, like sir said, we are going. So now I am giving the size. Okay. And now movement is a little should be not, no movement should be done. Okay, like running or moving, walking, it should not be done. I am giving it an area. Okay, so
area का क्या इसका area?
no, so it is like what is going on. It is doing raster. Okay, it is going raster. Okay, so first we have to see the vertical is 0 0. It's all right. Everything is set. Now we are going to first as soon as we select this NCHR, there comes an NCM sweep which defines the frequency of operation of this tip. Okay, so in non-contact and tapping mode we have this frequency, but in contact mode there is no frequency because it works on the force, only force. Here what happens is there is NCM sweep. So it will show the frequency like at this position, at after approach there is a minimum distance set by this set point. Okay, and then it shows like it is the frequency that the tip is making all the time. Okay, throughout scanning. So the change in the amplitude of this frequency, change in the amplitude of this frequency, the frequency of the tip will define the topography. Okay, which is being reflected through this, and you will see the topography here in this topography. Okay, so this is the NCM sweep which shows that 349.7. We have the here the table of each of the tips having different frequency. Okay, so we have to match with this, and I have already matched, so that is okay now. So, and the other thing is that what we have to do is the channels, like what we are going to study. So in this case we are going to study this, see these are MFMs, so we have to clear it, and so all means NCM. Okay, so we are going to study NCM, non-contact mode, amplitude, phase, topography and error signal. So let's add all and apply. Okay, these have been applied. Now we have to approach the tip to the sample. It is currently it is at a certain height. Now we are going to approach. The tip is going down. Okay. Now we are good to go. So I have on the line scan.
5 micron.
And I have given the area, say 5 micron. So it is showing something. Okay, it should be topography. So this is the topography. This is error signal good. NCM amplitude. We are not interested in this. So this is a depth. It is showing a depth. Okay, and the sample I will show after. So yeah, let's increase 5. Then there is, I think, some sort of dust. Okay. 20. So it is going. 40. might be the circular one. Okay, so 50 is good enough. So we are currently going in this direction. Okay, we are doing this. And now what about this vertical? So we are where? Something on the grids. So there is no deflection is being shown here. Okay, a little deflection of 5 angstrom, and which is also not that. I may give the offset so that it may go a little shifted to this position. Okay, on this grid. So you will get the dip up, what the sample is. So a little deflection in X, say 1. See, okay, you are getting something. Okay, that means we are at the edge of this, and now we are going to start. But before that, let's see whether the forward and backward, okay, raster scanning is well matched or not. So the forward and backward topography is nearly matched. We can see. We can give a try of 1.2 gain. So we are adjusting we are adjusting for the feedback signal. Okay, we want this much of amplitude. Okay, this much of amplitude throughout my scanning. So it will maintain the this 13.796 nanometers. Okay, that amplitude throughout the scan with this feedback provided through the controller. Okay, to this head. So it will maintain this height and give us simple force of 13.796 throughout the sample. As it goes up, down, it will maintain this through the feedback loop. That is the use of the feedback loop, to maintain this set point. Okay, so now I think we are good to go. Let's do it a little matching. Okay, 13.25. Okay, ma'am. Now let's start. Since the sample is a little tilted, you can see here, it is not that straight. So that's why you are seeing this kind of, okay.
सिखाई थी धीरे धीरे जितना आप सिखाएगा.
Yes, this is, you can get an idea, like this is my sample, this kind of. Okay, so basically topography is like height, you can get the exact, but the x and y, okay, the horizontal component dimension, it may vary. What happens is, this is the tip, okay, not by showing this, let me tell you, like this is the tip. Okay, so as soon as you go up, you go farther from the tip, which is connected to the cantilever. Say it is cantilever and the tip is attached. This is the tip and it is attached to the cantilever. So somewhere there. Okay. So the tip at the very bottom is of like atoms, barely few atoms. And as soon as we go up, gradient, high gradient change in the atom number. Okay. So there are lots of atoms. So it is kind of this conical. Okay. So if this feature and this tip, the tip here and the feature, these are having a larger difference in the number of atoms. See the interaction here is before it is getting interacted to this part of the substrate. This is getting interacted with this. Okay, your sample of having so much height. Okay, so that it is interacting with the upper part of the tip. So what it will do is, it will not let you do this and then this. It will let you this. So you cannot exactly get this like a sharp jump. You will get a jump like curvy. Okay, so that's why it is not exactly giving you the data of x and y, but it will definitely give you the data of Z. So Z is the precise tool. The XY you can not change, but it is not that not that fixed.
इसकी जो सर हाइट वो भी सिंपल है, उसमें जो भी एटम का हाइट है मॉलिक्यूल का हाइट है दोनों से रिलायबल
Height is totally reliable. You can totally rely on
because I
that.
did DLS, then I
No.
found a different size and
No.
I did AML, then found different sizes.
So we are done with this. So it is to lift the tip. Okay. So we are now lifting the tip. Okay. I don't think that we can perform AFM in this limited time because it is so much sophisticated that we have to get this out hole and then again insert the new tip. Before inserting that tip, we have to magnetize that tip. Okay, that is why it is named MFM. Anyways, so we have so what MFM do? Let me explain at least. What MFM do is MFM simply we have to magnetize the tip. Let me get the magnetizer. What it really do? So here is the tip holder. Okay, we have to put the tip like cantilever this side. Okay, inverted, and close this. Okay, and this is the tip magnetizer. We have to magnetize the tip for 5 minutes. Okay, after being magnetized, we have to get out the tip, place it on the head, and then put it there, and the rest part is like setup. We have to go to the tip that is mentioned here, MFMR maybe or maybe multi 75 EG. So this is MFMR. We have to select this MFMR. Okay, and then after selecting MFMR, we have to select this MFM mode. Okay, and then those channels which are already present, MFM phase, amplitude, okay, topography and all. So in MFM you can do topography. Okay, in MFM itself you can do topography, and apart from that you can do the MFM to get the magnetic domains of your samples. Okay, like how your sample isn't your sample magnetic or not. So you can see that. We are having the data, at least we can show you the data. See, MFM forward. This is the software XEI, which is provided with this Spark XE7. This system name is XE7, Spark XE7 from Korea. Okay, so these are the domains. You seeing this, the dark and the light ones. Okay, so these are the magnetic domains. It has been patterned like this. So this is the standard sample that they have provided. So similarly, we can also check like whether our material is magnetic or not. We cannot get the exact idea like it is paramagnetic or diamagnetic, okay, or ferromagnetic, but we can get the idea that yes, our sample is magnetic material. So further you can do squid. Okay. So this is all about MFM. So any questions?